Okay, welcome to part 3 of my assembly language editor program, the Metal Assembly Language Editor. I have retyped the Hello World program, so let's just load that. And here's our familiar Hello World program. If we exec hello, you can see it still prints Hello World 10 times. At the end of every exec, it always shows that status bar, gives you the values that are stored in X, Y, accumulator, your flags. It does not show the program counter because it's not simulating this program, it's actually running it. So there's no way to save the program counter when you return to the editor. That's wiped out. It's pulled off the stack to return to the editor, and that's all there is to it. So program counter is not included. Anyway, let's go up into banked RAM. Let's go to A000 and let's say bank, let's go to bank 2C. You can see this bank is completely empty. I'm going to set a label here. And if we go back to our main program here, I'm going to move POIT and PRST up into bank RAM. There's 23 bytes here. So if I go move POIT, PRST, move POIT to temp, 23 bytes is 17. Okay, so now we're in bank 2C, and you can see POIT and PRST are there. If we went back, you can see they're missing here. Let's delete this. Okay, so that's nice now. You can see the file end marker has now reduced to 083B. Now, since these routines are in bank RAM right now, as long as the bank number is 2C, it'll be fine and it'll run. But if the bank number changes, this program will crash. What we have to do is insert 3 bytes here, and we'll go down here and insert 3 more bytes down here. And I'm going to change these subroutine calls to var calls. So byte bank number PRST, and we'll change that now to JFAR. I'm going to do the same thing down here. Byte bank number POIT, and we'll change that to a var call. And now if we exec hello, it works. Let's go up into POIT, and let's just change our bank number here to, let's go to 12. And you can see there's nothing in this bank. And I'm just going to set the label here, temp, move from POIT to temp 17. Now we're in bank 12. If we go back, nothing happens because we're still in the same bank. If we go to bank, what bank was that? 2C. Yeah, you can see that it's all been wiped out now. If we go to NARF and look at our main program, you can see that the bank number has now changed here to 12. And program still works. Now I'm going to move. So I've moved from low RAM to bank RAM. I've moved code from one bank to another bank. Now I'm going to move code from bank RAM back down to low RAM. So we'll set the label temp here. Oh, that's not the label I want. SLBL TEMP. Yeah, changing a label name is that easy. Just go to the label and type SLBL again. I'm going to move from POIT to temp 17 one more time. Now you can see it's there. Now the file end marker is still here. We have to change our file end marker. I'm going to go FEND. File end marker at the top right is now 0858. So if, let's say we want, the reason I changed that is so that I could do things like this. I can insert 3 bytes everything moved down. If I hadn't changed where F end was, it would have overwritten point because that was at 0841. But since I moved the file end marker down here, everything moved there. So we exec hello, that changed. Now all of these labels changed position except for the strings. So if I go up here to the start of the strings and insert 4 bytes, now that's all moved down. All of the strings have changed their location, and as you can see, the low byte here now corresponds to the correct low byte. Same for this one. If we go here, F5, and we'll go into the middle of this and say, we don't want to say hello to the world. We want to say hello wharf. And we'll go F1 here and delete 01, hello wharf. So yeah, the string length has changed. When a string length changed, all those labels changed positions. If we go back up here to here, we'll delete those 4 bytes. They all moved. Everything changed to correspond with it. So that's how you move stuff around. If you want to copy some code, let's say we want to copy a block of code. Let's go back to our bank 1-2 where we had point before. I'm going to put a temporary label in here. And now if we go to narf again, I'm going to copy hello to temp. And let's see, 6, 12, 18, 22, 24, 26, 27 bytes. So that's 1B. So now you see a copy of that program here. We can set a label, temp. And if we exec temp, well, it does the exact same thing. Go back to narf, and we can see our hello is still there because we only copied rather than moving. So that's how you can copy up and down between banked RAM and low RAM. All the metadata follows your code around when you do that. When you're typing in code, the fend marker automatically increases as you're typing, so that it'll always keep track of where the end of your file is. It's only when you do things like I did down here, copying point down from banked RAM to low RAM, that you actually have to adjust your file end marker. And that's about it for copy, move, insert, and delete.